So given time constraints, maybe I should go ahead and start. Is that okay? Good in the back? All right. Well, thank you all for coming. My name is Paul Clarke. I work in the Linux Technology Center at IBM. My role there is as a software architect and software developer. I work on things like performance tools, portability tools, core libraries. I touch a little bit on the compiler, things like that. I've been in IBM for a long time. I've had a number of different roles. I've been a consultant. I've been a performance analyst. I've been in AIX development, all kinds of things. So I really appreciate you all coming. There's a lot to cover. Part of the motivation for putting this together is if you are in the business where you might need to port or tune applications for Linux on Power, there's a number of tools that IBM has helped contribute to or make available to make that effort more of a success. And the awareness of those tools may be lower than what we hope for, and we want to make sure that we get the best results we can as quickly as we can. There's been many cases where, as a consultant, you get into a porting effort and it just takes a little too long, the customer gets a little antsy, and you really want to get those best results as quickly as possible. I really appreciate Chris from OSU doing his presentation earlier. It was very interesting that they were able to port, 2,000 applications in a short amount of time with a relatively inexperienced resource. Porting is generally a very easy process, and probably maybe I think you said 70%, maybe even higher, are just recompile and go. Interpreted languages are portable by nature. So this really talks about the times when you try to port something and it isn't an easy process, where you run into some difficulties. So let me go through, because I don't have that much time to cover a lot of material. Like I was saying, one of the points of putting this presentation together is to get all these tools kind of in one place, so you can take what I'm saying, because I'm going to talk fairly quickly, in the reference material, look at it later, maybe go through it and digest it a little better than maybe what you're going to be able to do today. The tools are listed here. I'm not going to go through them because I'm going to talk about them. I do kind of divide the tools into different scopes in terms of where they're applicable. White box, gray box, and black box. White box tools are tools where the user of the tool basically is expected to have the source code and the willingness and ability to change the source code for portability reasons or for performance advantage. Gray box is where you have the source code, but you may not be willing to or able to change the source code, because you want to look at it from a performance standpoint, so you can be able to recompile, relink, things like that. Black box is where you may not even have the source code, but you want to do some analysis. You want to look at the code, see if you can make it perform better. Let's move on. Who here has heard of the advanced toolchain? A few? So advanced toolchain. So the advanced toolchain is a suite of some of the latest and greatest compilers, libraries, performance tools, analysis tools, things like that, built in an optimized fashion and made available for your use. And the reason that it exists is most of the time when we're working on a distribution, the distribution's motivation is often stability. So years ago, they've settled on a certain compiler, a certain level with the libraries, and they stay with those for stability reasons. And there's really nothing wrong with that. But from a performance standpoint, IBM is trying to carry the ball forward. New processor architectures are being announced, Power 8, Power 9. All these things may have come out, after the distribution has settled on its library level. But we want to make sure IBM invests a significant amount of effort in taking advantage of the new features and functionality in the new processors, as well as incorporating new optimization algorithms and whatnot. So if you don't use the new compilers and libraries, you won't take advantage and exploit the new capabilities of the processor as efficiently. So advanced toolchain is really designed to fill that gap, to give you those new compilers, new libraries on the existing distributions. It is updated regularly with security fixes and feature updates. It is supportable through the IBM support line. It's all open source. It's available with that link there. The advanced tool chain, the most recent version is AT 11.0-3. It has GCC 7, and you'll see why that's important in the next chart. glibc, binutils, boost, updated versions of that compared to the distributions, as well as a host of other tools, libraries, and compilers, as you can see at the bottom there. I wanted to give you an idea of what the real value of the advanced toolchain is compared to a distribution. This is not to pick on Red Hat. All the distributions kind of tend to settle on older versions of the library. But here you can see the distro is settled on 4.8 for the GCC version. The advanced toolchain has 7.3. This is the latest release of GCC 7, has a lot more Power 8 and Power 9 performance advantage. And in the center column, you can see that Red Hat has made strides in a similar area. They provide a developer tool set, which makes available to developers one of the latest releases of a compiler, version 7.2, so very close to latest, and the latest version of binutils. But one of the things I wanted to draw into is the advanced toolchain makes the libraries available. So not only are you getting the latest libraries available for like libc, libn, for malloc and the math routines and whatnot, you also get those libraries built with the advanced toolchain, so you get better code generation in those libraries as well. One thing I wanted to note on this chart is when you build with the advanced toolchain, the application result has a tie to the runtime of the advanced toolchain. So if you want to deploy that application elsewhere, you have to bring the advanced toolchain runtime with you. This is just something to be aware of. It is a free offering, so it shouldn't be a significant problem, but definitely something to be aware of. If you've worked on AIX, I know at least some in the audience are familiar with AIX, the proprietary and flagship compiler that appears on AIX. The XL compiler suite is also available on Linux. This is the compiler that's used on the spec publishes that IBM makes. So it is expected to provide some of the better optimization techniques. It is the version most people are familiar with, the licensed and supported version. But very importantly to a porting effort is there is a community edition, which is free and full function. Previous editions of the community edition were slightly handicapped with respect to the optimization levels that were supported, but the most recent versions are full function. So basically the only difference between the two is the support. Another interesting aspect is newer versions of the XL compiler also use a new front end based on Clang, which will make source code compatibility between GCC and XL much more better. So it should be an easier effort to adopt the XL toolchain. Another nice feature that allows for collaboration between the XL compiler offering and the advanced toolchain is the optimized libraries that come with the advanced toolchain can also be used by the XL compiler. So you maybe get kind of the best of both worlds, the flagship compiler and pre-built system libraries that are fully optimized for the architecture. In addition, going beyond just basic compilation, XL offers some neat advantages where with compiler flags, certain compiler flags, you can generate automatically parallelized code, which is really neat for the Power platform due to its broad throughput capabilities. In addition, they have added partial support for OpenMP 4.5, and utilization of those OpenMP 4.5 primitives allows transparent exploitation of the GPU resources on the system. So that's a really nice function. In addition, the XL compiler brings along optimized math libraries, MAS and BLAS, and these libraries can actually be used again with the advanced toolchain. Some customers have been found not to be real excited about using a proprietary compiler, so in this case you can use some nice libraries with the advanced toolchain if XL compilation is not an option. A neat feature that also is available with XL is optimization reports, where running the compilation with a certain option will produce these reports, and you actually analyze these reports and find areas where the compiler was not able to do certain optimizations because of restrictions that it found in the code. So you may be able to go back, reanalyze the code, maybe restructure it a bit for performance advantage by making some changes. FDPR. This is an offering out of IBM Research. This is it's a neat post-link binary optimization tool. So it doesn't require any recompiling or relinking. It basically takes a linked executable, instruments the code, runs a representative performance scenario, and then can go in and restructure and optimize those binaries basically in place to give you a better performing binary program. The reason there's a gray box here instead of a black box, because you really don't need source code, is that you will probably need to relink. There is a requirement in FTPR to preserve relocation information. So in the link step, you have to add a flag to do that. So relinking is often required because that is not the default behavior. FTPR is a free download, and there's some ease of use wrappers which allow kind of one step to handle that three-step process. And I'll show you a run through of that scenario here. Here you can see we build the code with that preserving the relocation information in the first step. And the second step does all three of the three-step process. It does instrumentation of the executable. It will run a profiling run, and then it will optimize the executable, producing a new executable in its place. And you can see down at the bottom, there's a couple of runs there. You can see we've improved the performance here about, what, 6 or 8%. This is a bit of a silly test because if you can see at the top, I didn't even optimize the code going in, but it is an example of a case where you can see FTPR has an impact. I've moved to a white box here because FTPR also provides the opportunity to produce a journal. Once it's done its optimization, instrumentation and data collection phases, it can analyze the results and write a journal out which will give some indication of changes that can be made to the source code such that you can actually go back and change the source code, maybe not even need FTPR to perform its magic. You can actually change the source code, which will benefit the code ad nauseum. You can change the code permanently, so you don't have to keep doing FTPR over and over. What appears in that journal? This is an example, maybe a little too small to read, but if I can interpret it for you, this is a case where FTPR found an example where a function was being called over and over. This function was small enough so that the call overhead was high, and inlining that function would be advantageous, from a performance perspective. So you get the file, line number, and you can go right into the source code and analyze to see if there's ways of getting that function inlined. IBM SDK for Linux on Power. Who's heard of the IBM SDK for Linux on Power? Okay, so this is an offering from IBM. It's a fairly substantive offering. It's an IDE, so Integrated Development Environment. It is based on Eclipse, so it has all the features and functions that if you're an Eclipse user, if you're familiar with or comfortable with Eclipse, it is that with IBM plugins targeted at porting and tuning C and C++ applications for Linux on Power. It is built to run on Linux, both on x86 and Power. If you're a Windows or Mac user, you can run it on those systems, but you have to do it through a virtual machine. It runs in 3 different modes. You can run it obviously on that Power system and remote display back with various techniques. You can run it entirely on x86 if you're comfortable with using cross-compilers and emulation technologies. One of the examples I came up with on the way here is if you're on an airplane and you don't have your Power system sitting under your seat, plugged in and ready to go, you can do some basic Power development right on your laptop without even access to a Power system. You can also run the SDK in a hybrid environment where the IDE itself runs on your laptop and the development environment is seamlessly accessed to a remote Power system. So you kind of get the best of both worlds, the interactivity of a locally running IDE and the Power development environment that you really want to use. It is a free download. I've written a tutorial that kind of walks through a very typical use case scenario where you can bring up the SDK, use the most valuable and frequently used tools, and get the most value out of the SDK with the least amount of effort. There are also some videos available if you want to watch some walkthroughs of those tools being used. Basic operation of the SDK. You basically want to import your source code. Then there's a series of plugins they may want to run. This is in rough order that you might want to run them, not mandated. And I'll talk about each of these plugins in later charts. The Migration Advisor is a portability advisor. It's a source code scanner. I'll talk about that in a bit. After you've ported the code, got it built successfully, the build advisor in the SDK will look for things like, are you using the best compiler? Are you using the best compiler flags? Things like that. Source code advisor is a runtime performance analysis. And then people that are doing performance analysis are probably familiar with perf no profile already. And then I'll talk about CPI Breakdown and Power Performance Advisor later. Migration Advisor. So one of the first things that needs to be done in porting is to get the thing ported. And like we said earlier, that's often no effort at all. But sometimes it does take some effort. So the Migration Advisor is a plugin in the SDK that does source code scanning, looks for a lot of these different portability issues and concerns, and will display a report for you directly in the GUI, which I'll show you in a second, and allow you to analyze to see whether that is indeed a portability issue and something that needs to be addressed or not. The nice thing is it's very easy to run. It's simply import the code and then click on the project's context menu and click Run Migration Advisor, so a very easy thing to do. There's also some neat features about quick fixes, and I'll describe that in a little bit. But essentially, that is the way for the SDK to actually go in, and if it has high confidence, it can actually fix the code for you. So, you know, with a large project, going through each one and fixing it for you is going to be tedious, so there's a way to do that automatically for high confidence issues. Here's a picture of the SDK in action. So we've just run the Migration Advisor. The report is at the bottom, in the bottom frame. And you can see it's found here, I guess, 7 different issues displayed. I can put my glasses on so I can read them. There's a couple of cases where it found a preprocessor macro. Oftentimes, if you're familiar with the porting exercises, you will often find code with legacy x86 bias, where they'll have ifdef x86, run some fast path, else slow path. So these are the kinds of things that the Migration Advisor wants to flag for you, so these are things you want to look at earlier just so you don't stumble into them later. Also, a number of the other issues it found were using compiler built-ins, and I'll talk a little bit about that in a bit. I talked about the quick fixes. This is an example of an x86 built-in using MMX SSE type compiler built-ins. These are not compatible with Power, but if you get that report, you find these things, you can actually hover over that code. You get a pop-up that kind of describes what's going on, and then the blue hyperlink, if you click on that, what it'll do, it'll actually go in the code and fix the code for you in a portable fashion. So the code will not change semantically from what it was before, but it will now be portable to the Power platform, all with one click.
That's huge.
It's pretty nice.
That's huge.
So here's even better. Nice segue. So the SDK, when you initially set it up to run, you can click another box that says apply these fixes automatically. So if the SDK has high confidence that what it's about to do is correct, it will go through, scan the source code, and implement all these fixes automatically. So if you have a lot of code, this is going to save you a lot of time. So, excuse me, Source Code Advisor. This is another plugin in the SDK. This basically, if you recall, I talked about FDPR a little bit earlier. This is a GUI plugin that's based on FDPR. It will do the same runtime performance analysis. It will generate that journal, import that back into the SDK automatically, and then display those areas of the code where these issues were found. Similarly to the way the Migration Advisor works, it will also offer quick fixes. Here's an example of Source Code Advisor output, where it found a couple different issues where there were inline function possibilities for performance advantage. It describes the problem, gives you a potential solution in textual form. The other thing you can do is double click on those line descriptions there, and you'll go straight to the source code, hover over that, get a description of the problem as it was found, and you click on this hyperlink. It'll, again, implement that fix directly in your code. Here you can see on the bottom right, there's an attribute applied on line 24 to force the compiler to always inline this function. CPI breakdown. So CPI, cycles per instruction, that's a metric often used in performance analysis. That is a measure of a processor efficiency. How well is your program executing on the system? How many cycles does it take to execute a typical instruction in your program? Obviously lower is better. But that measurement in itself doesn't really tell you what's going on, what makes it high, what makes it how can you address trying to get it to not be so high. So the breakdown tries to, will break down that single metric into a hierarchy of hardware events where you can do further detailed analysis based on the characteristics of the processor under load. One thing to note here, that sad little note at the bottom, is that this plugin doesn't currently have support for Power 9. It does have full support for Power 8, which is a perfectly valid platform for doing some similar performance analysis, and improvements for Power 8 will translate fairly well to Power 9. This is probably too hard to read, and that's okay. This is an example of CPI Breakdown has just finished, and this is a display of the hierarchy. So going from left to right, we're going to get more and more specific in terms of the hardware events. The events on the right are folded into the events as you go towards the left. The highest, most frequent events encountered are highlighted, red, sort of a pink, and then orange. I did not pick those colors. So you can kind of visually zero in on the most important events for more detailed analysis. Now, these boxes aren't to scale, so we added something called a radar chart, which kind of gives you an idea of which areas to look at more closely. The other thing, I want to go back a chart, and you can't see it, but each of these boxes is filled with a hardware event mnemonic, so they're not really readable. If you hover over these, you can get a nice description of what that mnemonic really stands for. The other really cool thing is if you double-click on these boxes, the SDK will automatically launch a new run of the perf command for the representative performance scenario and profile on that specific event. And then you'll get the same output. I've already talked about that. You'll get the same output that you did before with perf, where you get information based on which lines these events are occurring, but it's for that specific event that was happening in your code. So you can really do some really detailed analysis based on specific hardware events, not just cycles. In addition, you can break down further, not only by the line in the source code, you can go into the assembly and find some really detailed information about where hardware events are occurring. So GUIs are very powerful. We just walked through a bunch of exercises where that's useful. They're not useful in every case for every customer. Some, it's difficult to apply in an automated fashion. If you have thousands of projects you want to port, it's difficult to run them all through a GUI. From an IBM perspective, it's expensive to develop and it's expensive to get right. Usability is always a concern. And some customers just don't want to use GUIs. So what we've done over the last year or so is we've tried to migrate some of the more used and more valuable tools from a GUI to a command line implementation. So I'll talk about those a little bit. They're all open source. They become part of your cafeteria of tools, and they are part of this GitHub organization that we're going to keep adding tools to over time and improving. Migration Advisor, I talked about the GUI version of Migration Advisor 4 before. This is the command line version of that. It's very similar in technique. It scans the code. It reports portability issues and concerns. It has, I think, basically the same list of checkers that I showed under the earlier GUI version of the Migration Advisor. It does not have the quick fix capability, so this is basically going to be a report that you could review and manually remediate. I'm going to keep moving. Here's an example of the report where it found a couple of instances where a non-portable API call was being invoked. And then a similar example to before where an ifdef was found. So that might need some visual inspection to find out if there's a slow path for power there. Source Code Advisor, I talked earlier about the GUI version of the Source Code Advisor. This command line version of the Source Code Advisor, again, the very same technique, leverages FTBR, collects that journal, generates a very visual and very readable report. The command line version does not have the quick fix capability again, so again, this is a manual effort. These things are a work in progress. I believe it should work with Fortran. I don't know if we've done a lot of testing with that, but anything where the correct debug information is emitted should be good. Yeah, yeah. That won't be the case for the Migration Advisor. Migration Advisor really works with C++. All right. Here's an example of the output from the Source Code Advisor. This is a case where in the code it found an issue where a store was followed very quickly by a load, which forces some flushes and its performance disadvantage. Gives you a description, gives you an idea of what something like it might look like, including a potential remediation. Another case where an opportunity for inlining a function is recommended. I talked earlier about the CPI Breakdown Tool. This is a command line version of that. Basically emits the same information, a two-step process. It will do a perf. It will run perf and gather all the performance information that it needs to display the CPI breakdown. And then the CPI display command will display that. Let me show you output here. This is edited because otherwise you get a very deep output. So this allows you to kind of really see what hardware events should you focus on for further analysis. And speaking of which, let's see, so another thing you can do is kind of filter the events so you can eliminate some of the very small and less occurrent events. The other thing that's not in the charts here that was just added within the last few days is an automatic drill down capability. So that will run through some of these more frequently occurring hardware events and automatically run another profiling run for you, drilling down on those specific events and give you source code level information. So you can actually look at which specific events are happening, where they're happening, so you can manually do some analysis and see if you can find ways to mitigate that. So speaking of tools that were released in the last few days, this tool was also released in the last few days, also at that GitHub organization. If you're familiar with AIX, AIX has a command called CURT. It is a utilization reporting tool. We took that idea and re-implemented it in Python to run under the perf command. So you can collect a series of perf events and then run that, the perf script command against that with this Python script and get all kinds of information about utilization. You can get it per system-wide, per process, per task. You can get user time, kernel time, idle time, system call time, hypervisor call times, all kinds of information. Task migrations, how much time is being spent in interrupts for each task, etc. So this can be a nice tool for situations where your utilization isn't as high as you would like, and the power systems are quite capable, so you really want to get that utilization up high. Here's an example of the output, possibly difficult to read, but it does show you a particular task. This is a curl command that I was running. You can see off to the right, the utilization for this task is only 3%. Very low, but that might be expected for a task that's going to be waiting a lot for network input. Gives you all the system calls, how many times they were invoked, how much time total was spent in those syscalls, average, minimum, maximum per syscall, hypervisor calls that were invoked, some very nice information, detailed information about each task. Also a system-wide information. What's your system doing? How much time is it spending? This system was 9% utilized, as you can see on the far right there. So pretty low utilization. In this case, it was expected. Anyway, so hypervisor calls, all the things that might give you some information about where you might want to look if your utilization is lower than it should be. Power functional simulators. This is a full system simulation capability. It basically simulates an entire power system on your, for example, your laptop. You can get access to a power system without having the need for the actual power system. Great for basic development. I talked a little bit about earlier about if you want to run an entire power development on your x86 system, this is one of the things that allow you to do that. It will provide a single core, single thread, so the environment is fairly limited, although it does have a Power 8 and a Power 9 system, so you can do some early Power 9 development. And there's some ease-of-use wrapper scripts at the OpenPOWER SDK organization and GitHub. So what does that allow you to do? So you can take your x86 laptop, run a single command. It runs through firmware boot. It runs through operating system boot, and you get all the way down to a PowerPC 64LE login prompt. And from there, you can do whatever you want. This one is a Debian image, I believe, so you can actually install packages. You can install the advanced toolchain. The performance will not be like a power system, probably not surprisingly, but it is pretty good. It's certainly interactive and usable, so might be something to check out. Performance Simulator, this is a tool that takes instruction traces and it will run it through a cycle-accurate power cycle simulator. So that might be interested if you're going to do some really fine-grained analysis. It's basically a tool that feeds output into other tools. The actual output can be viewed directly with some included viewers. Just a quick note that it uses Valgrind's iTrace command, and that iTrace command is not normally part of Valgrind, but it does come in the Valgrind that comes with the advanced toolchain, which is the first tool I mentioned way back. Just a quick run through of how to use it. You take the trace of your scenario. There's some ways of kind of limiting and filtering the trace that it collects. You have to do one conversion step, and then you can run the instruction trace through the timer, and then you can run the viewers. What do the viewers look like? So here's a viewer. You see all the instructions laid out on the right. And on the left are all of the cycles being spent for that instruction in every different phase of its existence, from fetch to completion. And then each of those cycles is annotated. You can hover over those, get some information about why is it delayed. For example, here the cursor kind of in the middle of the screen is hovering over one of the lowercase s's. And you can see at the top, there's a description that says that it cannot issue because the sources are not ready. So this is an example of an instruction that's waiting for one of its operands to come from a previous instruction. Another viewer that's included called JViewer is very, very similar, just a slightly different output. Here I've picked a different instruction that seems to have a long delay. This one is delayed, for example, I hovered over a U. That's because the unit is not free, so you have some contention on processor resources there. So again, this is really low-level analysis if you want to get to that level. Again, speaking of tools that have been released recently, this is also released in the last couple days. So this takes those cycle-accurate reports and will go through and generate an enormous amount of statistics, frankly, for the data that's included in those reports, and tell you where are the most executed loops, where are the most executed misaligned short loops, incorrectly hinted branch instructions, all kinds of things. So if you really want to get down to this level, this thing's very handy for compiler writers, but if you want to do some really fine-grained analysis on your compilation code on your power systems, this is a fantastic tool. Here's an example of output. I'm not going to go through that. The typesat tool actually comes with some very good documentation, which explains what it's doing and what all this information means. One thing I do want to highlight, just as an example, is there you can see in the middle, I've kind of highlighted it. This is a branch instruction that had a bad hint, right? So it's only taken, you can see off to the right, the prob flag says it's taken about 35% of the time, where the hint said take it all the time, or nearly all the time. So this is a bad branch instruction. The modern processors do a very good job of predicting branches. And in fact, most modern compilers don't even issue code that has branch instructions anymore. So this may be a case of where you're running code that was built with earlier versions of GCC. So that might tell you need to maybe use the advanced toolchain to get the newer libraries on your system. PVecLib, this is a suite of vector intrinsics that are not part of the Power ISA, but are likely to be useful to the users of vector code. Higher order functions, not directly implemented in the ISA. It is open source in the form of header files. I'm not going to go into a great amount of detail here. Here's a list of some of the functions that are included there. This is C, yeah. And then I'm almost done, I think. How much time I want to do on time? Speedy is another toolkit that sets up some neat capabilities for inter-process communication, where you have a shared address space between processes, so you can actually pass pointers back and forth between processes. It can make inter-process communication more efficient. built on that basic infrastructure are a couple of neat capabilities like lockless logging, so you can have multi-process logging, which is a task you really want to it's kind of a necessary evil, but you'd like it to get out of the way, so if you can do it locklessly, so much the better. On top of that is multi-process producer-consumer queue that are lockless. And also there has another thing where you do fast timestamps. Instead of calling get time of day, which is going to be a system call, you can do it with a single instruction, move from special purpose registered. Last thing I want to talk about, take a breath. LPCPU is a tool kit we use to collect data on a customer system if they're reporting a performance issue. We've made that available to the public. That's been out for a while now. There's not that much awareness of it, though. It does some really neat stuff that I use. It's a two-step process where you collect the data on the system and then you can offload it all in a big giant tarball and then post-process it somewhere else, and it generates some nice graphs and collects a lot of really useful data using the suite of tools here, and can provide, here's a run through of how to use it. Basically, you just untar it, run it, and then pull the data back off and post-process it in an included script. It can generate some really nice graphs that are interactive. You can zoom in, zoom out for processor utilization, instruction counts, dirty memory, things like that. Last thing I wanted to talk about is support. Only a couple of these tools are really officially supportable through the IBM support line. That's the advanced toolchain and the XL compilers. But what we'd really like to do from an IBM perspective, from a community perspective, is develop a lot more of the knowledge base in the community to get the internal communications more external, so that people that are encountering issues on the Power platform know where to go to talk about those things, to solve kind of what I might call the Google problem. If you find a problem on Power, can you Google for it and find the answer? So there's a Linux on Power developer portal. It's new within the last year or so. It replaces the the DeveloperWorks Linux on Power community. Within the Power developer portal, there's a DW Answers forum, so you can ask a question. Experts in IBM and elsewhere are monitoring those forums, so hopefully you'll get an answer fairly quickly. As well as the general forums, we want to encourage discussion there, so Stack Overflow, Server Fault, etc. And then if you're willing to tolerate the latencies in IRC, you can talk on the IRC channels as well. I think that's about it. I put some random clip art up here so you can have something to look at, but there's no significance to it. I thank you for your time, and enjoy the rest of the conference.
Paul, I would say that the
Yes.
XL compilers in the community remove a lot of the concern about proprietary compiling.
Yeah.
And I think that that's a really important piece of this, that people put more faith in it because of the fact that they're not being stuck down one road or feel like they can go so many other directions.
Right, right. So the question was concern about lock-in if you're using the supported version of the XL compilers. Having the community edition kind of makes that lock-in less of a concern. Yeah, thank you. Yeah, that's a good comment. Yeah, I'm glad they removed some of the feature limitations too. So now it's basically you get what you get. The only limitation is support. So, yeah, good comment. Thank you. Any other questions? Thank you.